Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ms. Linda. Today, inshallah, we're going to solve practice questions for grade 10, Unit 2, non-stop. In this unit, we're going to study about work energy theorem, kinetic energy, potential energy, and power. So the first thing, we're going to start with work. Now, work in physics, W equals force times displacement cosine the angle theta. I have three cases. Work could be positive, could be negative, or zero. Now, when do I have a positive work? I have a positive work if force and displacement are parallel, which means if I have a box and I'm pushing this box to the right, this is the applied force, the box will move certain distance d. So F and D are in the same direction, they're parallel. The angle between them is 0. And we know cosine 0 equals 1. So in this case, we have a positive work. Now, work is negative if the forces and displacement are opposite to each other in opposite direction. Like if we take the same example, I have here a box and I push the box always opposite to the direction of motion. This is the direction of motion or direction of acceleration. Opposite to the direction of motion, we have here friction. Could be kinetic or static if the object starts about to move. So here we have, suppose we have a kinetic or dynamic friction. Now, the object will move in this direction. So the direction of displacement here. So the opposite to each other, displacement and friction force, the angle between them is 180. And we know cosine 180 degree is -1. -1. So if you have friction force, usually, always, the work is negative. Now, if, for example, I'm pushing the wall, and the wall is not moving, for every action, there is opposite an equal reaction, the wall will push me back. So the force that is being applied, since I don't have no displacement, that means we have no work. Work is 0. Or I could hold my bag and walk. So this is me. Now I'm holding my bag with my hands and I'm walking. So what are the forces that's being applied on my bag? I have the weight of the bag down and the applied force up when I'm holding the bag. These forces are equal, are balanced. So applied force and direction of displacement, they are perpendicular to each other. The angle between them 90 degrees. Cosine 90 degree, cosine 90 degree is 0. So in this case, work is 0. Now I'm going to solve one question, one example to illustrate that. We have here a worker. A worker pushes 1.5 times 10 to the power 3 in Newton crate. Okay, so here we have a crate and the worker is pushing the crate. Newton, it's a unit of weight or force. So the weight of the crate, Fg, is 1.5 times 10 to the power 3 Newton. With a horizontal force, So this is the applied force. The value of this force is 345 in Newton. The crate will move distance 24 meters. Meter is a unit of distance. So the crate will move in this direction. Distance, the value of this distance is 24 meters. Assume the coefficient of kinetic friction between the crate and the floor. So the coefficient of kinetic friction, this is in mu K, 0.22. How much work is done by the worker on the crate? The worker, this is the force that has been applied by the worker. So if I'm going to use this formula, W equals FD cosine the angle theta. The applied force and displacement are in the same direction. The angle between them is 0. So F applied times D will equal 345 times displacement is 24, cosine 0 is 1. So this will equal 8.28 times 10 to the power 3 joule. Second question, second part of the question, how much work is done by the floor on the crate? By the floor, that means we have a friction force, and we know the force, the work done by the friction is negative. So W will equal the friction force times D, and I know it should be negative. Now, how can I calculate the value of the friction? Friction is a mu K times a normal force times D. And we know normal force is opposite here in our case, is opposite to the weight of the crate. So Fn, the normal force, will equal the weight of the crate, and both of them will equal 1.5 times 10 to the power 3 Newton. So just substitute. W will equal minus 0.20. 2 times 1.5 times 10 to the power 3 times the distance D, 24, and don't forget I should have negative, and the final answer is negative 7.92 times 10 to the power 3. The unit of work is joule or Newton meter. So if you write joule or Newton meter, both are correct. Last thing, find the net work on the crate, just add them. Suppose this is W1 and this is W2. So W net work is a scalar quantity, just add, we don't care about direction. So add these two values, W1 plus W2. And if you add them, you should get 3.6 times 10 to the power 2 joule. Okay. Now we're going to go to kinetic energy. Now these questions, I want you to try them yourself. Okay, just apply the formula, substitute and apply the formula. Let's solve this one, this question, the last one. If 2 joule of work, so here I have W, is done in raising 180 gram of apple. Gram, it's a unit of mass. So this is mass. How far is it lifted? So I need the distance. You have an apple, and I raise this apple up. So here I apply the force. Now, to raise it up, this force should at least equal to the weight of the apple. Should at least greater or equal the weight of the apple to be able to lift it up. Now, how can I find the weight of the apple? Is mass times free fall acceleration. But remember, before solving any physics questions, you have to make sure that the units are consistent. Now here, joule is SI unit. Joule SI unit, while gram is not SI unit. The SI unit for mass is kilogram. So I have here M, 180, just divided by 1,000. When you divide, it's the same as multiplying by 10 to the power negative 3. So here we will have 0.18 kilogram. I need the weight now, the weight of this apple, M times G. 0.18, I'm going to take G10, 10, okay, 10 meter per second square. It should be 9.81, but for simplicity, I'm going to take 10, and this will give us 1.8 Newton. I need W, so W will be Fg times the distance D, or the applied force, because this is the work done in raising. Raising is the applied force. We said applied force and gravity, they're equal. Okay? They're equal. This in the same direction, so it's positive. And this will give us the value of W. I'm going to substitute in this equation is 2 equals the applied force. This one, the applied force, will equal Fg, 1.8 times D. I need D. Divide both sides by 1.8 by 1.8. And you will get D equals 2 divided by 1.8. This will equal 1.1 meter. 1.1 meter. Okay, now we're going to go to the kinetic energy. Now, kinetic energy is the energy the object possesses when it's when it's in motion, when I have the object is moving. Kinetic energy, the formula for kinetic energy, I'm going to take the first letter, K, E. This will depend on the mass of the object, M, times its velocity square. So kinetic energy half mv square, half mv square. Now let's solve question number. This is the first question. One of the world's fastest helicopter, okay, has a stop speed of 4.4 times 10 to the power 2 kilometer per hour. This is the speed. So I have V, the velocity or the speed, equals 4 times 10 to the power 2 kilometer per hour. At this speed, if the kinetic energy at this speed, so the kinetic energy here is 2.1 times 10 to the power 7 joule. What is the helicopter mass? What is the helicopter mass? I need M. Okay. Now, first, we have to check the units. If the units are consistent or not. Here, I have kilometer per hour is not SI unit. I should convert it to SI unit. So what I'm going to do, since I have two units, I'm going to open two conversion factors. The first conversion factor to convert kilometer to meter, and to convert hour is down on the denominator, to convert it to what? To second. So next to the prefix kilo, I'm going to put 1 kilo. I'm going to put it down to get rid of it. The word kilo, it means 10. The prefix kilo, it means 10 to the power 3. 1 hour now, 1 hour, just I put it on the top, on the numerator to get rid of it. 1 hour, 1 hour is 60 minutes. And 1 minute is 60 seconds. So 60 times 60, 3,600. So I'm going to multiply 4 times 10 to the power 2 times 10 to the power 3 divided by 3,600. That's what I'm going to do. So it's will equal, okay, will equal 4 times 10 to the power 2 times 10 to the power 3 divided by 3,600. And this will give us 111.1 meter per second. Now I can substitute and find the value here. Okay. So I'm going to use the formula on the top. So kinetic energy just substitute in the formula. The formula is 2.1 times 10 to the power 7 equals half. I need m, so I'm going to keep it as it is, times v squared. V is 111.1 square. Now square this value divided by 2. Okay, so I'm going to use the calculator. Square this value divided by 2. We have 2.1 times 10 to the power 7 equals 111.1 square divided by 2. A big number. I'm going to round it. So if I have 6,171.6 m. Now, m and this number, they're multiplied by each other. I need the variable alone by itself. Okay, so these are multiplication. Since you don't have any sign, positive or negative, so multiplication, the inverse of multiplication is division. So I'm going to divide both sides by this number, 6,171.6 divided by 6,171.6. And then you find m. M, after you do that, it's around 3,000. So let's do it here on the calculator. 2.1 times 10 to the power 7 divided by this one. 3,402 kilogram. Don't forget the unit. Kilogram. Okay. Now the last question I'm going to solve is question number 2. Okay, this one. Question number 2. Here, let me take this question. I'll take it and solve it on the board just here. Okay. Now I have 7 kilogram bowling ball. The ball, I'm going to take the first letter. The kilogram, it's unit of mass. So M for the bowling ball is 7 kilogram. This is MB. Moves with a velocity 3 meters per second. So that this is the velocity of the bowling ball, 3 meters per second. How fast? How fast? It means I don't know the velocity of what? The table tennis ball. I'm going to take the letter T for table tennis ball. If the mass of the table tennis ball is 2.45 grams, again, a gram is not SI unit. So either you divide by 1,000 or you multiply by 10 to the power negative 3. If, now let's continue the question, if they have the same kinetic energy, that means the kinetic energy for the bowling ball should be the same as kinetic energy of the tennis ball. Now write the formula. This one here I have m for the bowling ball times b squared for the bowling ball equals half m b squared for the tennis ball. Half and half, they cancel each other out. Now just substitute. This is 7 times, you open bracket when you multiply. Don't put the cross sign. Okay. Now V is 3 squared. This will be equal to MT is 2.45 times 10 to the power negative 3 times BT squared. Okay. Now simplify. I have here multiplication. The opposite of multiplication is division. to keep this variable alone by itself. So divided by 2.45 times 10 to the power negative 3. 2.45 times 10 to the power negative 3. They cancel each other out. And I need VT, not VT square. So take square root for both sides. So VT, after you calculate this one, you should get 1.6 times 10 to the power 2. Don't forget the unit, meter per second. Meter per second. I'm going to stop here and then we'll continue the rest of the worksheet in the next video, inshallah.